Hello, 8th grade students. I hope everything's going okay. This is my first time doing this, so we're going to see how it goes. You should have already taken down section 7.1 notes, which is on understanding solutions. This would have been your interactive notebook assignment. So I just want to go over what you would have done for that. A colloid definition, it's where you can't see through it. A solution, which you can see through it, and a suspension where you can see the individual particles. And I'll give you some examples of that in a minute. Underneath that, you would have seen or written down the definition for solute and solvent. Okay, so what this is supposed to show is you have your solvents, which in this case we can think about it as being water. It's a thing in the most abundant substance. All right. So if it's a colloid, you take the solute and you put it in the solvent, and you can't see through it. You can think of a colloid as milk, right? You can't see the individual parts, but you also can't see through it. For a solution, you take the solute in the solvent, and you put the solute in the solvent, and you can see through it. You can think of this as sugar water or salt water, or even tea, where you can kind of see through it. You can't see the individual particles. For a suspension, it's where you take the solute in the solvent, put the solute in the solvent, and you can see the individual particles. An example of this would be a snow globe, putting pepper and water and shaking it around. And if you check out the notes, there's actually an example of a suspension for children's Tylenol where you can see the individual particles, and you have to shake it before you actually give it to the kid. Right, so that's what we would have done. But for today, on the right hand side of your notebook, what I want you to do, and this is going to be tricky, what I want you to do is copy this down, and you're going to have to pause because I can't get it to fit all on one screen. So what I want you to do is go ahead and pause the video right here and copy that down, and so go ahead and pause it, and I'll be there with you in a second. Okay, once you have that copied down, what I need you to do is copy the rest of it down. So I think you probably have from freezing down to still copy. So go ahead and pause the video here and go ahead and copy that down. Okay. So now that you have that all copied down, let's go over what it means. Okay. So what I want you to think about with this is, why do we put salt in ice when we're making ice cream? Why does the salt make the ice colder? And also, sometimes you put salt in water when you're cooking noodles. Most of that's flavor, but it actually does also increase the temperature of the water, and this is the reason why. So the question on the interactive notebook assignment is, why does salt, which is the solute, increase the boiling point and decrease the freezing point of water, which is the solvent? Okay, and we've already gone over phase change, but just as review, boiling is where you have enough energy to make the molecules escape or come out of the container. So in pure water, in the covalent bonding unit, or the bonding unit, you should remember that water is polar and water attracts to itself, right? So the positive and negative ends line up, and it's only that attraction between the water molecules that keep the water from escaping. So all you have to have is enough energy to overcome that attractive force. Right? If you have salt in the water, and salt is ionic, so it has positive and negative charges on it, the water wants to stick to the chlorine and the sodium ions, so the salt actually keeps the water down in the container and what keeps it from escaping. So it takes more energy to the water to get that water to escape. So the attraction of the water to salt ions keeps the water from boiling. Right? Oh, dear, I forgot to do that right there. There we go. Okay, now freezing, it's a little bit more complicated, but not too terrible. Freezing is where you remove enough energy where the molecules stick together, right? So in freezing, it's kind of the opposite of the boiling. Well, it is opposite from boiling. Water easily attracts to itself. So you remove energy until all the positive and negatives line up with the molecules, and it makes a crystal. And that's what ice is. It's a crystal where all the positive and negative charges are all lined up, right? What happens when you put salt in the water is the ions get in the way of the water connecting. So this sodium ion right here is keeping these two water molecules from attaching. So you have to take out even more energy to get the water molecules to attract. So the salt ions get in the way, and that's why that's written there. Just as a little side note with the ice cream thing, if the water molecules were actually attached like they are here, if this sodium ion was to squeeze its way into between the molecules, that would be separating the water, and that would be considered an endothermic situation where energy is being taken in. And if energy is being taken in, you feel it as being cold. And that's why putting salt in ice makes the ice colder, because that splitting apart of the water molecule takes energy to do. And where's it getting that energy? It's getting from the environment. And what's the environment? Well, the environment is the ice cream you're making, which makes the ice cream mixture colder. So I hope that makes sense. Go ahead and finish the notes if you haven't done so. And there is a quizzes under there. If you could go ahead and take the 10 question quizzes, that would be great. Okay. Hope you guys are doing okay. Okay. Bye-bye.